Mhm.
To remind us. Wow.
What was your question again, Esther? You want people to see if they understand what are the data types?
Yeah.
Okay.
Different, like, because I remember we mentioned some, actually more all of them during the last session.
Yeah, I think Faith is answering you there. Boolean, set type, text type.
Dictionaries, we've got dictionaries, we've got numbers as well, maybe tuples.
That's good. Yeah, I guess you remember. Oh, that's encouraging. So I was about to think, oh my God. So thank you. Yeah, these are the data types we mentioned last time. Oh, so yeah, we mentioned the text types, numeric types, Boolean, mapping sets, and sequence types. So I kind of touched on the numeric data types, and we looked at them when it comes to operations. So I would not cover that as much today. I believe part of that numeric continuation will be done by Ibra. So today we look at the other data types. Remember I mentioned that there are some things we could do with sequence type or mapping type or strings, and I'd like to cover that today. So strings. So strings are just characters that are in between quotation marks. So Python accepts both either single quotation or double quotation marks. So for instance, if yes.
Go ahead, Esther.
Hello?
Go ahead.
Oh. Okay. I hope I'm clear.
Yeah, you are clear, Esther. You're
okay.
good.
All right. All right. So with string, you can accept both double or single quotation marks. So this when I type in Esther and Wambui, Esther has double, Wambui has single quotation marks. So let's see what, remember we said if you want to see the data type of an object that you've created or a variable, you use this type function. So let's print out let's just confirm whether Python actually interprets this as strings. So if we run this, you see now class string. So as we go on, we'll understand what this class means because it's very important. So str, remember it stands for string. So, and we can do various things, and we've been seeing that in our assignment. We can combine strings. So, and that is it's a plus sign. The way we do operations with numeric types, we can use the plus sign for strings as well. So, and I think we've been using that quite a lot. So, like for instance, maybe you wanted to say like, my name is that. So remember, first name and last name was Esther Wambui. And if I run that, you see, we have a concatenation. I think we have done that quite a lot. So one thing that we cannot do is we can't do this. If you try and run this, say, instead of writing first name, let me try and change this to, let me say we have a variable called age. No, I think for me, I am a visual person and I like to see stuff working. So maybe because now age is given it a numeric data type. So let's see if I add the value age, what happens. So let's see if it will give us the same output. So you see, it shows type error. And one thing you need to know, we learn from errors, and when you read your error, you'll actually realize what the problem is. So it says type error can only concatenate string and not int. So we are trying to concatenate a string and an int, which Python does not agree. So what do we do in this case? What we do, we have different ways of doing that. And one of the ways is you can use the format method. So you write I am and then the curly braces where you would like your int to be placed. And then now after writing the statement, you use the dot format. So like here, when I run this, it works now. So I am 26 years old. Or another way that Python accepts is you can put whatever, instead of using the plus, you use commas, and that works too. So this is how you can concatenate a string and a non-string type, maybe an int or a float. So basically, I just wanted us to go through that because I believe maybe in the assignments, we might be going through such kind of issues. And this is how you might solve them when you're doing some of the assignments or when you're working, because you would need sometimes to add to, put different data types together, or like when you're writing a statement, you'd need to add variables that are strings to, a particular string. So those are some of the common not activities, but common functions you do with strings or numeric types that we didn't mention during the previous class. So one thing that I'd like us to concentrate on today are Python collections. So we said Python collections can be either sequences or the mapping types. So today I will look at lists, tuples, and dictionaries. We use them quite a lot, and you will be coming across them a lot, and you would need to manipulate them in different ways. So as we mentioned earlier, we said that lists can be changeable, and they allow duplicate values, and they are ordered. And we'll now try to understand why this definition is very important when it comes to lists. So how do we create a list? You can either, put values inside a square bracket, or use this list function. And take note, it has two brackets, and then you write the items that you need to have in the list. So if I run this, so we have two lists. We have this first list that has 10,97543, and then the other one that has Nairobi, Mombasa, Nakuru, Kisumu, and Machakos. So sometimes you would want to see how many items do I have in my list. So for example, how many items do I have in the list that I gave variable towns? So if I run this, I commented this out. So we have 5 items in the list. So we have 1, 2, 3. If we count them, there are 5. We can as well check, what about numbers? How many items do we have in numbers? So we have 6 items. So we have 6 items in numbers and 5 items in towns. So now we can access items in a list. And how do we do that? Now, that's now where it comes to the point of a list is ordered. So we order a list in terms of indexes. And in programming, we always start counting from 0. We don't count from 1, we always start counting from 0. So the first item is always indexed 0. So indexing is like how we order them using indexes. So for instance, if I want to find the first number, the first item, sorry, in the numbers list, or so I would say index 0. And then if you like to find the last number, you can as well do index -1. That is one way. So if I run this, so this is 10, as you can see on our list. 10 is the first number, 3 is the last number. So in addition to that, you can actually find items in different positions. So if I say found square bracket index 2, this means that I am looking for the third number because we start counting from 0. So I look for 0, 1, 2. 2 is the third item. So we expect to have, let's see, we expect to have Nakuru as our third item. So if I look for this, if I print this second item, I get Nakuru. So another thing you can as well do, you can print a range. So maybe you want like from the second to the fourth number. So what happens is when in a range, it's normally the first index is inclusive, but you exclude the last index. So in this case, we would print index 1, 2, and 3, which would be the second, third, and fourth. I hope we are together on that. Okay, I hope you're together. So this would print the second, the third, and the fourth, which is index 1, 2, and 3. It does not count index 4. That's how the range works. The same, we can as well do the same thing and print the first, like up to the third item. So we print 0, 1, and 2. So if we want to put a number before the full column, it starts from the beginning up to and excludes the last, like if it's 3, it will reach 2. It won't count 3 index 3. So if we run that, we see that we have index 0, 1, and 2. And the same case happens if we put a number at the beginning, but don't state where to stop. It will go up to the last number. But you remember, in this case, we always say that the first number is included. So in this case, it will start from index 3, and count 3, 4 up to the last. So we just have 2. So we have that. So I hope that is how we are able to access items in a list. The next is we can actually now change or update the values in a list. So how do we do that? So like it's just we now always have to use the concept that a list is ordered. So if we want to change the first number in the list called numbers, we would reference it by saying numbers index 0. So we want it to be 9. It was initially 10. So if I run this, so sorry. Our original list was 10, 9, 7. So now the first number 10 has been changed to 9. We can as well update lists in other different ways. For instance, we can insert using the insert function. You specify the index that you want it to be at and the value that you want inserted. That is one way we can do that. We also have the append method. So what append does, instead of because you haven't specified the index, it would add the value at the end of the list. So it will add on top of the other items. So that is the difference between insert and append. With insert, you specify the index. With append, it adds to the end of the list. So in this case, so we have inserted voy at index 3. So we'd expect to have voy at index 3, and we would expect to have Eldoret at the end of the list. So if I run this, so index 3, so we count 0, 1, 2, 3, we have voy, and then we have Eldoret at the end of our list. So that's how we can update values in a list. So another thing we can do with lists is we can delete whatever we have just done or items in the list. So one, you can just use the remove method. So remove, you just specify the item you want to remove. So say I want to remove Nairobi. So I would say the list is towns dot remove Nairobi. So that removes the item, the exact item that you want, if you know exactly what you want to remove. If you actually don't know, but you know where you want it, like the index, you use the pop method and you now specify the index. You can as well use the delete. And then when you do the delete, you now reference the index. So you see so when you say numbers index 0, that means it's the first item in the list numbers. When I say towns pop index 1, that's the second name. So we would expect to remove Nairobi and the second name in the towns and delete the first item in the numbers list. So let's see that if that works. So now we are left with this. Oh, and I forgot to mention, we also have pop item, pop like without, if you don't specify in index. So see the first time we specified index 1. If you don't specify the index, it would automatically remove the last item. Remember, append adds the last item, adds to it makes it the last item, adds to the end of the list, append. Pop removes the last item in the list. So those are basically the basic things that you can do with a list. We've talked about how to create a list, how to read or access from a list, how to update a list, and how to delete items from a list. So we are going to look at the same thing for tuples and dictionaries as well. So remember last time we talked about a for loop. So you can actually, instead of looking at your list like this inside square brackets, you can actually print these items individually, and that we can do with a for loop. So remember we looked at for loop. So let's say if you want to just print out the names of the towns we have. So for name in town, you can do this. You can use this code and print it out. And one interesting thing that you can do now, remember we talked about concatenation. So we can actually concatenate this. So say, maybe let's say I live in. Then remember the concatenation, we just use the plus sign. So what we'd expect is that for every item in our list, it should concatenate. So this should happen for every item in our list. So as you can see, it has so that so as you see, these are some of the interesting things that we can do with lists and for loops. All these concepts that we are learning, don't look at them as independent concepts, but are concepts that build on top, are building blocks for how you write your code. So you can combine now you've combined aspects of variables, operators, data types now, which are lists, loops, that is control structures, which is iteration. So we are building and building, and that is how programs are made. We use all these concepts that we're learning, and the more we learn, the more we keep building on such concepts. So we'll now also look at another control structure that we learned. We learned about selection. So sometimes you might want to check, is this item in a list? So for example, I just made a simple program that maybe you wanted to find out if you have the list. You remember you have a list. So maybe you have a predefined list like the one we have here, numbers. So our numbers list have 9, 7, 5, and 4. So we want a user to enter a number. And if that number is in our list, which we reference as numbers, print the number is valid or print the number is invalid. So this is just a simple program that I would like us to, I just want you to visualize how to understand the concepts and how they're interlinked. So if I run this, so if I enter a number like 2 was not in our list, so gives me invalid. So if I run that again and enter a number that was in the list, gives me valid. So that is how we check. And we use keyword to the n in numbers to check if a value is in our list. Okay, so now we look at tuples. We said a tuple now is ordered but cannot be changed. So in this case, that means that we cannot delete items from a tuple. We cannot update a tuple. So we can only access, we can create a tuple, we can access or read from a tuple, but we cannot change it at all. So most of the times we use tuples maybe when you want to give values that are constant, that you would not want to be changed at any point in your code. That's when it's advisable to use tuples. And if maybe you would want to change it, maybe you change the tuple to a list, but it's a workaround around it, but built in Python, tuples cannot be changed. So the same concept we did a list, we can create, and we remember list square brackets, tuple normal brackets, but if you want to use the tuple function, you put the 2 double brackets. So So that's our tuple right there. So it's just like you see now, if maybe you have a database or something, databases are normally represented in forms of tuples. We wouldn't want to change, to something goes wrong and it interferes maybe with your user details. That's a use case of where we might need a tuple. And then the same things, how you can check the length of a tuple. So we have 4 items, as you can see in a tuple, that's the length. And so the same ways we access items in a list, same way that we do for a tuple. So we can print our first and last items. So Jane is the first item, 20 is the last item. So we can as well print the ranges of items. So this would print index 0 and 1, first 2 numbers. And then this would print the last 2. Then we can as well loop through a tuple as we have seen in a list. So basically how we access items in a list is how we access items in a tuple. Only difference is that a tuple cannot be changed. So a dictionary is a bit different. So dictionaries are represented in form of key value pairs. So what do I mean by key value pairs? Key, you have to, so this is how we create a dictionary. We create curly braces. The key is the first, like for example, in this case, the key is first name, the value is Jane. The key is last name, value is Doe. Key is email, value jd@gmail.com. The key is age and the value is 20. So that was what we mean by key and values. And we'll actually now see what is the importance of having these keys, what is the importance of having the values. So for example,
question. Can you have booleans as part of key value pairs as well?
Yes, a boolean is a data type. So let's try and see. No? So what key would you want that? So maybe we say
say if you say religious equals true, maybe.
all right. So we have our key as religious. Value to be true. Oops. So that's a representation of the key as religious and value as true. So we run this. So what does
Esther,
tell us?
the age 20 should be a comma there in order for this one to work. Yeah. Cool. Now try. All right. Cool.
So as you can see, Python has accepted it. No errors. Having no output sometimes is a good thing. So we can now check the length as usual. See how many items we have 5. So items, so it's the key value is represented as one item of the dictionary. That's why we have 5 items instead of 10. Then now you can now look what are the keys in this case. So the keys are what I mentioned. So we can also look and see what are the values. So you see, okay, you see your value true. It's a value that has been accepted as a value in our dictionary. So now here is where the difference comes in. This is now where we need to use the keys to access the values. So for example, so we want to see what is the value of first name. So we get Jane. So we access the values, like see for us, the Jane, Doe, to access those, we need to use the key to access it. And that's why we always say that items in a dictionary have to be unique, because we use the key to access the values. So you cannot have duplicates, like you cannot have two first name Jane inside our dictionary. So that's how we do it, accessing values. We only, this is the, so in lists and tuples, we do indexes, but in the dictionary, we use the keys. We can as well update. And to update, we can change now the values. There are different ways you can update a dictionary. We can just reference it, like the value. So you remember the value now here is Jane. So details, key, first name, we change it, make it equal to now Esther. Then another method is that you can use the update method. So the update method, you say details.update, then inside parentheses, then now how you reference a dictionary, like curly braces, we say now we want this key last name to now represent one boy. So when we do that, let's see whether our details dictionary will be updated. So it has updated our values. So now that is changing already existing key value pairs. As well, we can add like dictionary items. So how do we do that? We just now create, so this is now a new key. We have a key, cities, because now in this case, the details dictionary already exists. So we want to just add a key value pair on top of whatever we have. So we have the city and we reference it to Nairobi. Or still using the update method, we can create another key value pair, color pink. So if we run this, let's see, we scroll to the side whether items have been added. So city has been added and color pink has been added. So that's how we add or update a dictionary. So talked about creating, reading, and updating. Now we look at deleting. So to delete an item in a dictionary, we do the same. We use the pop method. In this case, instead of using an index, we use the key. So we want to delete the email key value pair, and as well we can delete the age key value pair. So we can use the pop method or the delete. So now, as you can see, we don't have the email and we don't have the age. So that's how we delete items from a dictionary. So an interesting thing is that the last item that has been inserted in the dictionary, you can delete it. The way we did the pop without an index, you can now do the pop item. So if we run this, definitely the last thing inserted was color pink. So if I run this, I don't have color pink as a result. We don't have it. So as well, we can look through a dictionary, but in this case, we use the dot items. So we can say for detail in this, the details.items. So that items references the item of the dictionary. So an item is like first name Esther. That is the item. So for detail in the dictionary items, you print the details. So we have now printed out our dictionary items as a list. So we will do the precedence and exception handling. Then we'll come and look at functions. Thank you. Any question about data types? Okay. Ibrahim, over to you.
Thank you very much, Esther. It's a very informative session. I hope everyone can hear me clearly. Hello.
Yeah.
We can hear you, Brian.
Okay, thank you. Yeah. Okay. In this session, I'll try to be as brief as I can and take the shortest time to take us through two topics. I'll be taking you through precedence and associativity and also exception handling. So I hope to see my screen. Yeah. So precedence and associativity. What's precedence and associativity in Python programming? So generally in programming. So in precedence and associativity, what we deal with here is the operations, the operators. You've heard of operators in Python. Operators are values like addition, multiplication. These are all operators. We have division, we have flow, we have many operators in Python that does different things. It's a numerical operations or even statistical, you can say it. So precedence is how does these operators work together in the form of which one comes before the other. So I think basically by definition, that is what precedence is. After this, hello.
Everybody more can check.
Yes. Yes.
Brian, go ahead. I'm sorry. Go ahead.
Okay. So as I said now, precedence is when you are dealing with these operators, different kind of operations, maybe when you're doing your coding, maybe you're having some numerical calculations or combinations, you need to use operators. It's unavoidable. In one way or another, you have a case whereby you need to use it. So the same like in mathematics, you have something like board math. When in case you're having numerical calculations, you're dealing with multiplication, division, brackets, subtraction, and so on. So in case you are having all these operators in one equation, which one should you execute first? Which one should go in first? So this is what precedence of Python operators is basically about. So there can be more than one operator in an expression, this is just like I said. So the rule of precedence, it's a guiding rule that tells you which operator should be done first in case you're having a combination of multiple operators in one expression. So let's say in like what we all know in our elementary mathematics, board math. So bracket is the first thing that should always be executed, that should be computed. And then, for instance, multiplication always comes before addition and subtraction and stuff. And then you have some operators which have the same level of precedence. So it is how what basically we cover in this precedence and associativity topic. Yes. Next thing. One thing you know, just the way the rule of BODMAS guides us. Same thing in programming as well. The parentheses that we say always bracket is one thing that always takes the highest precedence and multiplication and all those others. So for instance, let's compare parenthesis, bracket, and multiplication. Compare the two and see which one is computed first. So first thing I want us to go at least practical here and see what we can do here. So when you are talking of this precedence, maybe you are having something like 4 multiplied by 5 and then plus 3. Enter. See, the answer is 23. How did the computer, the compiler, did this computation and give us the answer as 23? Why not 4 multiplied by 5? Yes, plus 3. Why not something like 5 plus 3, which is 8, multiplied by 4, which is 32? Maybe you have something like 5 shift plus 4 multiplied by 3. You see, that one gives us 17. I mean, why not in the order of how it appears, like 5 multiplied by plus 4, 20, and then plus 3? Why not that way, but it gives us a different value? So you see, the computer already understands that it's a concept of the order of precedence, that multiplication should always be computed before addition. And even more than multiplication, brackets have higher precedence in that bracket has to be computed before multiplication. Let's have something like this. Let's incorporate bracket here and see which one comes first. Same calculation, let's say 5 plus 4 plus 5 multiplied by 3. So we're having the same values here, but we are having 4 plus 5, the first two in the bracket. And then we want to see what's the outcome. That is it. 27 is the result. So you see, in this case, with the bracket, the addition of 4 and 5 have a higher precedence to multiplication by 3. So basically, in simplest form, that is what the precedence is. So bracket have higher precedence than multiplication. The computer understands. So for whatever the values we give when you're writing your code, doing different things, it considers the order of precedence the same way you do consider them when you are doing your basic mathematics and you follow the rule of BODMAS and so on. But with programming, we have much more operators than what is included in BODMAS. We have many other operators with different precedence level. So this is how computer itself is programmed to understand and consider the rule of precedence. And that's the example. So going forward, same way I've explained now. In this case here, the bracket gives 10 minus 4 multiplied by 2. So with the bracket, we have a higher precedence. So the bracket is completed and then we proceed to the next. But in the second case here, the multiplication is done and then the subtraction comes after multiplication. So there are different kinds of precedence in Python. We have a number of them listed in this table. I have got this. So for instance, the same way we say bracket, parenthesis comes first with the highest precedence. So for whatever the expression you are trying to solve, the computer understands that it should be the parenthesis, the bracket that should first go in to be computed. And then it figures out if there is any other one. And the second one, you can see exponential. Exponential is power rule. When you're having a power to something like 2 raised to power 2, which is 4, 2 times 2, that is, or 2 raised to power 3, which is 2 times 2 times 2, like 3 times. So the exponential rule, the exponential functions, which is in simple as the power expression, comes in next after parenthesis. And then we have the urinary plus, which is the urinary plus is like you are giving a structure and expression for a value. The plus 4 gives you 4 is equal to the positive 4. And then we have a unary for both positive and the negative values. The next is multiplication. Here, we are having multiplication, division, flow division, and modulus. All these four of them, they have the same level of precedence. What does that mean? Literally, when we say multiplication, division, flow division, what we in case we are having both multiplication and division? So in short, the order of precedence for multiplication, division, modulus, and flow division is the same. There is nothing like, it doesn't make any difference if you compute one before the other. But in the precedence rule, all these are some of the things that are made, that are guided, that guides us on how we tackle these things that we have. So the same thing applies. You can go and maybe search and see much more. Addition comes in. Basically, these are just the BODMAS rule, except for a few. The bitwise shift operators, the AND operators. You remember we're using AND is maybe in case we are having the condition A and B, or bitwise or the line, the bitwise XOR, and so on and so on. So yeah, simply those are the list of operators that you can find in Python in the order, in its order of precedence as follows each other. So you see from the precedence, it means that all the operators that are in a group like multiplication, division, flow division, and modulus are at the same precedence level, meaning that there is none which should be must come before the other. So what does it mean now? What if you are having both multiplication, division, or even flow division expression? We'll answer that as we proceed. So now that is where the concept of associativity comes in. Associativity, it defines the order of operation. In case you are having maybe, for instance, all those four operators which have the same level of precedence and the same expression, in associativity, it tells us which operators, how we will do your computation. Of course, definitely you cannot do all of them at the same time. You have to do one after the other because these are one single expression and you have to drive to one answer. So the associativity is the order in which the Python evaluates the expression containing multiple operators of the same precedence. For example, yes, the product, the multiplication here, and the modulus have the same precedence, or the multiplication and the division have the same precedence. So there is something called left-right associativity. In the case you're having all the operators within the same level of precedence in one expression, then the left-right associativity is the rule that will guide you. Left-right associativity just simply means compute them in the order in which the first come, first serve basis. Left to right is when we write, we're writing from left to right. So from left to right, in the order in which they come in first, that is the order that you can use. But still, if you compute multiplication before division or division before multiplication, whichever way you will derive and come up with the same answer. It doesn't make any difference because the order of precedence for this is the same. So whichever, but the simplest way is you use the left-right associativity. The left-right associativity is you execute the expression from left to right. So whichever is it that the operator that comes before is the one that we compute, and then you proceed to the next. So basically that is left-right associativity. So and in Python,
is this always true in all packages, in all modules and packages? Does this stay true the whole time?
Yes, it's true.
Okay, thank you.
So maybe we can just try this and see for ourselves. It is maybe we say 4 multiply by 5 divide by 2. We have multiplication and then we have division, all of them in one expression. So which one should you compute first? Enter. The answer is 10 and 0. So in short, what it did is 4 multiplied by 5, that is 20, divided by 2, 10. Or rather, you can even say 4, you can choose to do maybe the division first. 5 divided by 2 is 2.5. 2.5 multiplied by 4 gives us still 10. So whichever you do, it will definitely drive to the same answer. That is why those two operators are in the same group of the precedence and the precedence level. You see, the concept is whichever you will compute, definitely the answer is the same because the precedence for both the two operators are the same. None should come before the other. They have the same level of precedence. But when you are having a long expression, then left-right associativity rule tells you you can move with the one that comes in first. So complete this from left to right as you continue. In case you have both multiplication and division, complete the one that appears first and then the next one. But whichever way, I don't think if there is any difference in the output. Maybe if you have 5 multiplied by, divide by plus 3 multiplied by 2. So you see, 5 divided by 2 multiplied by plus 3 multiplied by 2. You have multiplication here, and then we have two operators, division and multiplication, in this case, with the same level of precedence. You can just see and calculate because it's a simple one and see. 5 divided by 2, definitely multiplication and division have higher precedence than multiplication in the list. So we have to execute the first one. 5 divided by 2 is like 2.5. And then 3 multiplied by 2 is 6. 6 plus 2.5 is 8.5. Or rather, you can start here. 3 multiplied by 2 is 6. You start with that one. And then 5 divided by 2 is 2.5. And then you add the 2. Still, you drive at this one. So whichever you do, you get the same answer. But the easiest way is use the left-right associativity. Don't confuse yourself and ask yourself, which one should I complete first? Yeah. I think that is it according to how I understood this. And in Python, we have one exceptional rule. There is only one operator which has right to left associativity, and that is the exponential operator. I say the exponential operator is the power, the raised to a power, like a value, a number raised to another power of maybe 2 a power, whatever the number is. This is the only operator that has right to left associativity. When you are computing an expression with the exponential function operators, then in this case, we don't use the left-right associativity here. It applies differently. We use right to left. For instance, let's see an example of this. Maybe 4 raised to power 2 raised to power maybe 1. I don't want it to be 1, 2 raised to power 3. Enter. That's just a lot, very long number. 4 raised to power 2 raised to power 3. Let's just have 2 of them. 6, 5, 5, that's 6. In this case, we don't start from this one. We start from right. First, we have to compute 2 raised to power 3. 2 raised to power 3 is again 9. The next is now 4. After we have computed this one with our value 9, now we do the last one, which is 4 raised to power 9. No, 2 raised to power 3 is not 9, it's 8. Sorry. 4. Yeah, you see the values here, and the value here is the same. This implies that the last part is executed before this one. So we do the right left associativity. This is the exponential function rule. Exponential parent is the only one that follows the rule of right to left. It's inverse of the other. And you can see with the example how it works. You can keep on trying maybe with a few different other examples and see how it works maybe. and you can do in your mind, you can do the calculation and see if it works. With more practice, maybe you can see maybe the different examples and see, but basically the exponential function is the right place associativity rule. So let's continue. So we have an associative operand. So we have some operators such as the assignment operators and also the comparison operators which don't support associativity. Associativity is the rule that defines maybe left to right, right to left is some of the associativity rules that we have. So in this case, there is a special rule for maybe ordering of this type of operator which cannot be managed via associativity. So there are some operators which are non-associative. They don't comply with the rule of associativity that we've just seen and discussed. Maybe something like this, an assignment like this. 5, the condition 5 is less than 7, which is less than 9. Maybe in what we said earlier, we can say left to right is first 5 is less than 7, and then, sorry, 9, 7 is less than 9. This does not mean 5 is less than 7, which is less than 9, or 5 is less than 7 to bracket less than 9. Doesn't mean. In this case, there is no, it's non-associative. It doesn't follow that rule of saying maybe you start from left or something like that from right. No, it doesn't comply with those. So 5 is less than 7, which is less than 5 stands for itself, it's less than 7, and then 7 is less than 9. That is independent. It doesn't mean this the last two is less than the 5. No, the same applies here. 5 is less than 7 and 7 is less, and they get evaluated from left to right. But the concept is a less than, and it's just a logic, but it doesn't have any associativity whereby this one should come first and then the other one. And also in Python, we can have an assignment of a variable whereby you say A is less than B, which is less than C, which I mean equals to B, which is equals to C, which is equals to maybe 3. So you can use this condition to assign one single value to 3 different variables. Yes, so that is all about precedence and associativity. Maybe perhaps you have any question in this regards to the same.
One question, yeah. What's the limit? You said you can assign one value to 3 variables. What's the limit to what you can assign?
There is no limit with this. Equals to, there is no limit. You can pass in as many variables you have. This equals to means that A equals to B. Definitely, A equals to B means the value for A is the same as the value for B, which is equals to C, which is equals to D, and then you assign one value. So as long as
you the whole alphabet.
Yes. Yeah. So it can be anything. Maybe it can be something like name, maybe example is equals to example, D, or yeah, whatever it is. You for naming of variables, you can name your variables however you want. It can be a word, it can be one single character. Yeah.
I can do like a list of names and then assign the value male to all of those names. Then do another one, assign the value female to all those names.
Yes, if you want the same, if you are having the same value for all those variables, why not? Yeah.
Okay, I understand. Thank you.
Okay, thank you. So the next thing is exception handling. What's an exception? An exception is an event which occurs during the execution of a program that disrupts the normal flow of program instruction. So when you're running maybe a few lines of code, there are some cases whereby your program, your code disrupts the normal, stops giving you the required output that you expect. Maybe give you something like error, something like key error, depending on what the computation that you are executing, it can give you different output. So an exception is now an event whereby your computer raises an exception whereby telling you that there is something like this that needs to be done. Maybe you have something missing in your code, and then you will get the required output that you might expect. Maybe there is something you need to change. Something, yeah. So when a Python script encounters a situation that is out of the ordinary, then it cannot cope with, which it cannot cope with, it raises an exception. So this is now an object that represents an error. Though with errors, you can have many different kinds of errors, but for me, according to our understand, an error and an exception are just different words that describe the same thing. But for exceptions, it's something you can handle, and then there is a way of handling exceptions. But for an error, in case an error occurs in your code, then your code will definitely come to a point whereby it terminates and it's stop doing what it's supposed to, maybe just because of one single error. But for some exceptions, then there is a way you can handle, and that is what we are going to see with a few examples in this topic. So exceptions may indicate conditions that an application should try to catch. So maybe with examples as we proceed, you might get to understand what these exceptions are. Errors are the problems in a program due to which the program will stop the execution. And on the other hand, exceptions are raised when some internal events occur which changes the normal flow of the program. So these exceptions are raised by the compiler. For instance, what do you do when something bad happens to your program? Let's say you are trying to maybe open a file, then you type a wrong path, or maybe you have an indentation error. Or you ask the user for information and they type in something that's not what it should be. You don't want your program to just terminate just because of one simple line of code that maybe is done wrongly. You want your program to continue and give you what you expect. So in this case, you can pass in an exception whereby in case of such case, just give these outputs and continue executing the rest of the lines of code. So in one simple example using, we use exceptions, we handle exceptions with try or except. So I know at this point, you cannot understand what try and except does, but since exceptions are raised when the program is syntax, this program syntax is correct, but the code resulted in an error. This error does not stop the execution of this program. With exceptions, that error that does not, if you have an exception of code that exempts that particular error in your program, then it will not terminate there. It will give you, it will exempt that and continue giving you the output for the other part of the code. So first we have Python exceptions. Which kind of Python exceptions do you have? An attribute error. This is an error that when an attribute reference or assignment fails. So an assignment that we are trying to reference fails, doesn't. We have many other kinds of errors which can be, which are categorized exceptions. We have key errors. A key error is when maybe you are trying to, input output error. This is when an input out operation such as print statement or the built-in open function, or maybe just a method in short, fails for an IO related reason, e.g. file is not found. When you are trying to, in short, try to access maybe a file, and then maybe that file does not even exist. Definitely, it's not existing on your disk, on your hard disk, on your computer, that is. So you will get an IO error. I know some of these errors you have not come across, you don't even understand what this is, but as definitely you continue building and maybe doing more codes, you will get to come across most of them. But I'm sure index error is one thing that you have encountered. Key error is one thing that you have encountered. With the rest, you can continue learning. But for an index error, when you're having a list of items, and then you try to access maybe a particular item in your list, or maybe you are trying to access an element in a list which is not found there. You are maybe having only 3 items in a list. Then but in your case, in your code, you are calling the 5th item, of which we do not have 5 items in that list. you will definitely get an index error. It's telling you that the index that you are trying to access in that particular list doesn't exist. That is a kind of error that pops up. Now with exceptions, how can we deal with this index error and so on? The same applies with key error, except that the key error goes in for dictionaries. But all these are kinds of errors that we may encounter, and we have an exceptions for all of these. The common one here is maybe you can say type error. Type error is when an operation or a function is applied to an object of an inappropriate type. For instance, with type error, maybe you're having a variable that holds a string, and then you try to concatenate a string with an integer value. A string, you remember, it's characters, a list of characters, and then an integer is a numerical value or something like that. You cannot combine these two. Maybe when you are trying now to add these two together, you can either concatenate two strings, join two strings, or you add two integers like 2 plus 3, 3 plus 4, which is 3 plus 4 is the value. But you cannot say maybe Ibrahim, which is my name, which is a string, and then plus 5. Those two are different type of data type that cannot be combined. In this case, you get a type error. Basically, that's what type error is. A value error, I'm sure you have seen this. A function receives an argument in case that has the right type but an appropriate value. Maybe I know you have not gone much with functions and you don't understand, but it's when you are trying to tell your computer you are giving a value, a different value other than the one it's supposed to. Maybe you have a variable in the form of list, but then when now you are filling in your list items, you're giving, sorry, let's say maybe string, but when you are filling in the items, you give your something like an integer or maybe a float point. It will definitely give you a value error telling you that the value you have provided does not fit the variable that you have initialized. Zero division error basically from your calculators. When you do a number, you cannot divide a number divided by 0. The error applies to everything. The same mathematics concept. When you are trying to tell your computer to divide a value by a 0, definitely you will get that error. Something that doesn't happen, we call zero division error. So how do we handle exceptions? Basically, we have it in blocks of code when handling exceptions. They try, when you write maybe a few lines of code, there is definitely something that you create in your head, a specific output that you want. So you're giving instructions to your computer to do something. But in between that, there is something, an error that might occur. Maybe you are trying to access something that's not there. Maybe it's not in the right format. That is now the case. Instead of giving an error, you throw an exception. And so the try block, the except block is basically majorly the two part. So the except is execute the code when there is an exception, when there is an error. So for you to understand how each set of this block works in handling exceptions, let's go to the practical part of this and see it here. Our first part is here. What I did is I initialized a variable called myDict. MyDict is a dictionary. Then for my dictionary, you can see I have 3 elements. I hope you know dictionaries have keys and values. For every key, there is a value. A value for A is 1, B, and so on and so forth. Now, in this case, as Esther has already explained, you can try to access a particular key. A, B, and C, all those 3 are keys of this dictionary. 1, 2, 3 are its values. When you want to access a particular element of a dictionary, you can, this is how you access. Maybe let's say A. here value, here what we are trying to do is we are trying to access an element, a key in my dictionary, which is called A. You see? So when you're trying to access a values of a dictionary, you can use a key. You can call that key, which the key item, the name of your keys. Maybe if you want to access the B, then you just say my dictionary, and then the key by name A. And this will give you the values for this key. And remember, for every key, you have a value, key value pair. So, and that is how you access. If you know how you access items in dictionaries, then definitely you know what I'm doing here. Now we have maybe a scenario whereby in your code, in your line of code, you are trying to access something like D, of which D doesn't exist. We only have 3 elements, A, B, and C. And you say when you access the values of a dictionary using the keys, we use the same rule. Let's see what happens. Here we are trying to access D, which doesn't exist in our dictionary. So what does computer do? It will throw up an error, an exception, key error, whereby key error D. And key error is telling you that there is no keys like that in this dictionary. So in such scenarios, maybe you are having many other lines of code that runs after this. Your program will definitely terminate in case there is this. It wouldn't go past this. With the exemptions, you can add another line of code that exempts this error. You see, that is what is all about handling exception. We exempt this error such that your computer doesn't pop up this error, but it will give you a different output telling you that there is such an error, and then it will continue executing the lines of code that comes after this. So maybe let's see this now. With the same dictionary, the try block, what the try does is it's trying to tell your computer, do this. So when it does this, we give an example. Now the concept of exception is that instead of giving an error in case this cannot be executed, in case that error is an index error, just print this index does not exist and continue. In case maybe there is a key error, of which in this case, sorry for that, my computer is about to turn off. In case of the key error, then it pops up this output. Instead of terminating the whole code, this is how you send the error. So this is all what except does. So let's just run this and see what works here for us. Here, what we are trying to do is when we say try, we are instructing your computer do this, giving it a command. What it does here is this is the 2 lines of code that your computer will execute. In case this cannot be executed, then instead of going an error, we exempt the index error. This index error, in case there is an index error in your code, it's taken care of, it's handled. So it will not terminate, it will just go up. The index does not exist. If there is anything like key error, the same applies. Or any other error, print some other error occurred. So basically that is what exemption does. And then finally, we have another block that we call finally. What finally does, in short, is it just this part of code, in this case, regardless of what happens, regardless of exception or the value, the output, you're telling your computer to give this output to execute. So final is executed regardless of what happens before. It has to be executed regardless of the previous result. So, but with this one, you can see it later. So when we run this line of code, the output is the key is not in the dictionary. You see, here we are trying to access the element D. The same applies to what we did earlier on. In this case, we had an error, but here we do not have an error. But instead, the exemption handler is able to give us this output. Since this is a key error, we are dealing with dictionary, and we are trying to access a key that does not exist, meaning we have a key error, our computer just gives this output. The key does not exist. In short, it's telling you that the key of the dictionary that you are trying to access does not exist. You don't have that key. And then finally it executes this. Finally is what is executed regardless of what happens. So I hope you've seen what exception handling did compared to this here. We do not have an error. The key error that we have in this case has been handled, whereby we told this key is not in the dictionary. And maybe let's see and change this to something that we have and see if there is any difference. Run. In this case, our command is our line of code whereby we want this to be output is executed. You are accessing first item in this dictionary. So here I said, I'm accessing this item, this element using a key, of which A exists in my dictionary. So in case this exists, this is what is executed, unless you are having to access, in the case you are accessing different items other than what you're having here, then you have the rest of the errors. So I hope you can confirm and see the difference and or what the exception handler does. Proceed here. Let me just run. Here, this is a kind of type error. Here, what I did is that I initialized two variables, one which is an integer and the second one which is a string. What I am telling my computer to do is that I'm trying to say to add the two, 17 plus the drive, which is a string version and the integer and string. So I'm trying to get an output whereby you are combining these two variables, but with an exception handler. So the exemption that possibly occurs is a type error here. So I'm trying to say except a type error if there is a type error, whereby in case there is a type error, my computer gives me this output instead of giving an error and terminating the process, it will give you this output. So let's run this. Here, what we are told is the type of object cannot be combined. The exception, this part of the code is what is executed here, because definitely we cannot combine integer and string. That's what we want to do here. Maybe you can change this and say something like 3. Here we are having two integers and it can be combined. Let's see if we get it. Yeah. Here in this case, because I'm having both of them as an integers, this part of the code can be executed without drawing any exception. So that is why 17 and 3 are summed up to get 20 and not this part of it. So basically that is what the exception handling does here. So with the exception, the same way in our previous session, I was talking about sequencing, selection, and iteration. You can use exception with if and else, same way. In this case, what we do is here is I'm trying to access the first item of my dictionary, except if there is a key error. Key error is associated with the dictionary, please get that. So if there is a key error, it will definitely throw up this exception. Else, if it's not a key error, you are trying to tell your computer no error occurred. That is what you expect to be output. So if there isn't any exception, then this block of code is what will be executed. And finally, is a block of code that is executed no matter the output that comes before, no matter an exception or whatever it is, this part of code will always be. And this is most important in case when you are trying to access a remote file, and then you are having a finally close that file. Maybe you are accessing that file, and in case you happen to move out without closing the finally block of code, if you're having this kind of block of code, it will definitely close that file for you after accessing or maybe trying to retrieve the file from there. Yes, so regardless of what happens before this part, this is the block of code that will be executed. So in this case here, this else part is what is executed. And the same, if you are having an exception, these are the part of the code that is executed. So when handling an exception, you can try use else, if, and all those, just like what we do when dealing with selection and iteration. So in short, selection and iteration can be combined with exception. And with this last final example here, you can see a first line of code is I used the input method. Input is a built-in method that prompts the user to key in what you want. So the try is try this part of the code. So if the length of this input is equals to 9, then print your number is this. Else, in case this condition is not met, then that is basically what the else does, give this output. So instead of using else if, else even, something like that, I can send something like with except value error. We do not need a lot of that, because if it's either equals to 9 or it's not equals to 9. If it's equals to 9, this is the output. And if it's not equals to 9, then definitely this is the output. But what if the kind of values that you input here is not a string? Maybe it's something like character and something like not what it the variable, the kind of variable that accepts that value. Then in that case, you will get this exception. Instead of giving you an error complete in this case, now it will give you this output. So basically handling an exception is all about it. Let's say maybe for instance, enter your phone number. Let me key in my phone number. Okay. Your number is, so this is part of the code that is executed. See, sorry, this is what is executed. Could you try maybe something different and see what output you can get? Maybe run, and then maybe say something like that. This part of the code is, sorry, this part of the code is executed. The values doesn't meet the required length because the length should be 9, except for the value error. So yeah. Thank you. I think that's just a few things that I think can be much needed when you're trying to learn from the basic step. So with detailed code, definitely there's a lot more details that you need to know, the kind of errors, the kind of exceptions that you need to handle, but with more and more steps that we take, I think you get to understand this. But basically, that is what exception, how exception works and what it does. So with that few examples, I guess you got to understand something out of this. Thank you very much. Maybe if you have a question regarding the same, you can ask. So maybe if there is no any question, Esther, maybe you can take over from next. Good.
Oh, thank you, Bre. That was so detailed, and I hope you're not lost. I hope you're still together.
Yeah. You get in?
Yeah, I hope now we have much more to cover. I hope you're still alert. Can take like 2 minutes, then we can continue with functions. If maybe you have a question or not so far, are we good? Right. So since we are good, let's just continue with the functions. And now at the beginning, I remember we mentioned that Python accepts different paradigms. We talked about procedural, talked about functional, and object-oriented. So far we have been dealing with the procedural aspect of Python, whereby every line of code we write is executed one after another. So that is like the procedural aspect of Python programming. So now we're getting into the functional aspect of the programming. So how we use functions in Python is that we write functions, we just write some code, and that code is executed whenever we want it to be executed. We can write some code that actually is like line 20 and would be like between line 20 and 25, but it will be executed maybe at line 100, something like that. So, and what this helps us with is that it helps us like break down or modularize our program such that we can have different chunks of code that do different things for the same program. And this as well makes it easy and makes it easier for code. You don't have to rewrite, anytime you see yourself repeating the same thing over and over again when writing code, there has to be a better way of doing it. And that's where now things like functions come in, and this helps in the reusability of code, making it, saving time and you not being able to, and you not being, forced to keep repeating the same thing, of typing over the same thing. So, and this helps it maybe when you're working with larger programs for that purpose that I have mentioned. So, and how do the syntax of a function is quite simple, nothing difficult about it. So what we do, we use the def keyword, then we give the function a name, and then inside brackets, we enter arguments or parameters if needed, not necessary, it's not a must. Full colon, and then inside we make an indentation and then write the code that we want to be executed. You can as well add a comment to describe your function if you wish. That is how we create functions. So let's see how we can do it practically. So, okay, let's create a function. So let's say we want to create a function that greets you. Just says, hello, are you? So what do? We said we use the keyword def. We call our function greet. We have the bracket. Our function at the moment does not have any arguments or parameters. I will use the word arguments and parameters interchangeably because they mean the same thing. can either call them arguments or parameters. Mean the same thing. So ours does not have arguments, but it has a code that needs to be executed, which is print. Hello, how are you? So if I run this, nothing happens. Why? Because we have just defined the function. That's now meaning that this code is not, the print is not being executed. So how do we execute our function? We call the function. So how do we call the function? We say the name of the function that we gave it and the brackets. So that is how we call a function. And you see now it prints, hello, how are you? So we need to define a function and call it for it to be executed. So that is why I was saying, like, you can, if you have maybe 100 lines of code, you can define all our functions at the top. Then at the bottom is now where we call our functions, and we'll now see the aspect of different aspects of what I mentioned earlier of importance of using functions and how we can utilize functions in our code. So now we need to see how we can include parameters or arguments. So first we said we define a function. So we call our function greet as earlier, but now in this case, we give an argument or a parameter, call it name. And what should this function do? It should print hello, the name that we entered. So this name is a variable which references this parameter name. So we say, hello, the name, how are you? So that is the definition of the function. So when we call the function, we need to give the value of the parameter. So we give the parameter name. So what name do we want to be printed out? So let's say we want to say hello to Mercy. So we can print, so if I run this, that's how, hello Mercy, how are you? So Mercy, so we called the function and gave the parameter. The parameter is name. Name Mercy. And now we'll see, so you don't have to keep typing print, you don't have to keep typing print, hello, this. What you can do in the next time you need to do that is just call the function. So maybe you want to say hello to a different person. So maybe you want to say hello to let's say we want to say hello to Ibrahim. So we have not repeated any of the code, like the code, we'd already defined the function. So we just type this greet Ibrahim. So let's, if we just run this, it prints hello Ibrahim, how are you? So that is now how we say we don't have to keep repeating something over and over again. Once you define the function, you can reuse it. So you can also have more than one parameter. So we can have now, instead of just having name, we can have name and a place. So in this case, we would say hello and then insert the name. Are you from? Insert a place. So how do we do that? So remember, once you define the function, you call the function and give it the parameters or the values of the parameters. So in this case, we give the value for name is Helen and the value for place is Kenya. And if we run this code, it should say, hello, Helen, are you from Kenya? So this is now how we use more than one arguments or parameters. And one thing you need to note when you do this, the order of the parameters needs to match how you enter your values, the values of the parameters, and you call the function. So maybe let's say you forget and you call the function, right? So you call the function, and then you and write the place first. So let's say we say well, say Rwanda, and then you say the name. Maybe you say something. So let's see what this would do. It would print, hello Rwanda, are you from here? You see, so make sure that the values, that the order in which the parameters have been specified is the order in which you enter your values. But sometimes, we're always human, you can forget, and there's always ways to work around that. So how do we do that? That's where we have concept of keyword arguments. So we have the same code, which is greetings, the place name, and the same code, the same function. But so now if you notice, the place comes first, then the name second. You might forget, and you write name before place. So if you want to explicitly tell your function that make sure that Tom is name and place is Kenya. So now you're using keywords. So the keyword here, you make sure that the keyword argument means that you give the name of the argument and give the value. So name is Tom and place is Kenya. So if I run this doesn't matter the order in which you have entered, it will automatically place the value on the right parameter. So this is when now we need to be using keyword arguments. So it's up to you how you create your functions and how you call them. It's all up to you how to use them. But remember, when you use keyword arguments all the way when calling the function. If you don't want to use keyword arguments, you cannot mix the two. You have to choose which one to use. So something else that we can do is we can actually give a default value, like the value that defaults to it. So maybe we just say default values are Kenya, the place is Kenya, and the name is Anita. So in this case, anytime we call the function so let's first call the greetings function. Because now our greetings function in this case requires 2 arguments, right? Let's say we try and call it and not give it any arguments. Let's see what that happens. So it gives us a type error. Remember, we've talked about errors. And what is the error? Missing 2 required positional arguments. So when you want to avoid this, and it's not always like it's not only that you can do this. This is if the code you're writing actually permits you to do that, the logic. So let's say you can just call the function, and by default the name is Anita and the place is Kenya. So when you call the function, like that. Now, it actually says, hello, Anita, are you from Kenya? As well, you can now, this is just the default, but you can change this. So we can now give another place, say, Uganda or something, and then see. So if I run that, hello Joel, are you from Uganda? So it can accept the values, different values, but if in case maybe you don't give the values, it will now run the default values that you assigned earlier when defining your function. So let us look at some kind of practical thing that you can do with this. So maybe you want to calculate price. So, and maybe you are told, okay, this one they're giving 10% discount for items. So you create a function, say the price can vary, no? Any price of an item, but the default discount is 10%. So you can now create, so this is, you can now do any kind of code. You can even write like any kind of code that you want to work here and work. So you create a variable and call it total. And what does it do? Total takes the original price. Remember order of precedence. So it would multiply this first. So you price times, this is like calculating the discounted price. So maybe let's say you had an item that's 100 bob. It will calculate the discount would be 10 shillings. So 100 minus 10. So you get the total and then you round it to maybe 2 decimal places. And then you create print, please say yes. Remember, we talked about how to concatenate a string and a numerical value. So we have defined our function. So the concept is to realize that now our discount is the default. So you just tell the person, okay, now you call your function and enter the price. The price is 100. So we definitely need our answer to be 90. So yeah, our answer is 90. So maybe your item costs something different. Say it costs, let's say, 15,000. Oh, sorry. Okay. So yeah, if it costs 15,000, then the discounted price would be at 13,500. So now we have now defaulted to that. So let's say maybe we have our price and maybe you change your discount to maybe 100, but now we want to give our people, we decided our offer, we're done with the offer, let's just give them a 2% discount. So our price now becomes 98. So we now see how we can use default arguments, keyword arguments, and how that can work for us. So now when writing functions, we have a return statement. So a return statement basically what it does is when you call the function, the output would be the value that is returned. So what do I mean by that? So remember our discount calculator, price calculator, we calculate the price and get the total. So initially what we were doing is we were just printing out the value and that's it. That's all our function was doing. But with a return, you can return the value and do even more calculations with the same value. So this returns the total. So now here we have more than one argument. So what happens is maybe we want this function and it prints, like maybe you buy an item, maybe that costs 100 and you buy 3 of them. So, okay, let's just use the 2,500 that I entered and you buy 3 of them. If I run this function, it will give me a value, 750, but I can use this to do something else. So maybe we want to give our shoppers points, bonus points, assume. So we define the function as I defined earlier above. Same thing. So I would ask get an input. So we enter the price, we put it in a variable price, enter the number of items, we put it in the variable items. Now, what happens is now we call our function and give it our arguments. So now we're looking at two concepts. So we don't necessarily have to explicitly enter the values. Now, remember I mentioned we're building on top of concepts. And if we get lost, please stop me. So we now use the variables that we are entering in the price as the argument, like as the values for our arguments. Remember, we have a default argument, discount, but we need price and we need items. So price and items is now, let me use a different variable so that it kind of makes a bit more sense. Okay, let's say for variables. So now we enter, these are variables. So price and items were the parameters. Yeah. Now the output of our function here now. So we need to give now our function the values of the parameters. So that was the first price, any price that the user enters, and the number of items that the user enters. Okay. So, and whatever we get as the output, remember our function would return total. So this total would get stored in the variable total price. So I hope that is clear. So now, if that happens, we come and do a selection. So we say if total price is greater 5,000, do this, else if that's not the case, do this. So if we run our code, so enter initial price, say 1,000, enter number of items, let's say 3. So we get our price and thank you for shopping. So we now how we can use functions, and we didn't have necessarily to repeat this. I just wrote this just for us to understand, but if I just defined the function once, I would actually do the same I would either do this and this, using the same one function. I would write different sets of code that would do different things just by that one definition of a function. And lastly, there's just this one concept that might be really handy. We use it, and sometimes we might come across it. And this is a lambda function. So different from like a normal function, a lambda function is normally an anonymous function, like it doesn't have a name. And it's mostly used for writing functions that you don't require to reuse. You just need to use it once, you don't need to use it any other time. So you need to use it once and for all. So in that function, you use the keyword lambda, and it can accept as many arguments as possible, but only one expression. So what do I mean by this? So let's say we have a variable x, and then we have this. You remember we said it's just a variable that it's just a function that you use once. That's why we need to store it in a variable so that we can do something with it. So like lambda is the keyword, this a is an argument. Then you write a colon and then write the expression a times 2. So what does it mean? It takes just the same concept with the function. It takes out an argument a, or a parameter a, and then what it should do is multiply it by 2. So once you do that, we call now our variable that is stored in the function, and now give it the argument. So maybe we want to say our a should be 5. So if we run this, it should give us 10. And as I said, it can take up more than one argument. So maybe we have an argument a and b, and we want to multiply the two, a times b. So maybe we say 5 and 3. And if we do that, multiplies by 15. 5 by 3 get 15. And we use lambdas. One of the ways we can use a lambda is by now using it inside an already defined function. So what do I mean by this? We define a function called the multiplier that accepts an argument n. And now we need that n, we need to do something with that n. And we need to do it with not an explicitly defined value. Like we don't want to actually say, we just want n times as a number. We want that number to value. Like the way we're accepting user input, we want maybe the user can enter 3 or 2 or 5, for either the two. So what is now, maybe we want, so what it would return, remember the return statement, this function should return a lambda, should return that. So if I enter like the function and enter n is 2. So it should return that I need an argument a, and the expression is that a needs to be multiplied by 2. So now after doing that, we need to now supply the value of the argument a, and that value is 5. So if we do that, now we see it's 10. So I know you'd be wondering, like, so why do you have to do all that? So the good thing is now I can actually use with the same function, I can multiply different numbers, as many as I want. I can recycle the numbers. So I can do different things I can do diverse calculations inside a function. So this function can actually be adjusted according to what the user enters, or what you export, or what you specify. You can specify different values for one function. So that is the important thing. Also, in a lot of maybe data science or concepts, we use a lot of Lambda functions. So basically, that is the concept of functional programming, where we define a function, give it arguments or parameters, and call the function and perform various calculations or various coding aspects or programming aspects with our functions. So I guess with that, I'm done. And if you have a question, you're free to ask. Yeah.
That was awesome. Thank you very much for that.
You're welcome.
Esther, you done? Can you hear me? Esther.
I think her mic is gone just for a moment. It will come back.
Oh, okay. All right.
Oh, yeah. Yeah. I can hear you. I'm done. Sorry.
Okay. All right. So thank you very much for the presentation, Brian and Esther. Do we have anybody having any question? May need to answer. Anything you think was not covered properly, probably saw in the notes, which you probably need to be covered much more than what they did.
For me, it doesn't have to be answered now, but that idea of Lambda is just, I'm hearing Lambda this, Lambda that. I don't know where this idea of Lambda came from. So
Okay.
maybe I'll do my own research and find, or maybe if you know, you can tell me where this thing, I have a suspicion that it's a mathematics term, maybe it's a calculus term, and that might provide clarity. What do you think?
So Lambda could be in math, could be in AWS, but this restrict the Lambda to Python here. When you refer to Lambda as in Python, it simply means anonymous function. Function can return a value or it can just return nothing. When you declare a function, you can just declare it with at least something like a value to return or just at least a name. Lambda does not necessarily need that. So that's why they call it Lambda. Now, when you go into Amazon has something we call Lambda, where you can actually program your Python scripts in Lambda function, in Lambda in AWS. And we also have Lambda in calculus, or Lambda in calculation. So Lambda calculus, a formal system in mathematical logic for expressing computation based on function abstraction and application using variable binding. So that's something you can get in Google. But when we say Lambda in Python, this just, all you need to understand, it's an anonymous function. Function with a small, it's like, it's not, it can take any number of arguments, but can only have one expression.
Yeah,
So,
I appreciate that. That makes sense. I think that's enough to go on.
okay.
I'll definitely have more questions, but that's enough to go on for now. Thank you very much.
No problem. So what you might need to do is you probably want to practice with that. Make mistakes. When you make mistake, you fix it, then it kind of like sticks.
Yeah.
Yes, sir.
Okay.
Okay. Any other question, anybody else? All right. So this call has been recorded. And as soon as we're done, I'll go ahead and post it. So you can always come back to it. And please, if you have any question, feel free. No question is stupid question. Just feel free so we can revisit it so that you can understand it better. So if we have no any other question, then we can go ahead and call it a day. And I really thank you all for coming. It's difficult on a Saturday, especially in the afternoon. We have a lot of things, other things to do, but you all kind enough to attend this. So thank you. And thank you, Brea, and thank you, Esther, for the presentation, for taking your time to prepare. Thank you so much. All right, guys, you have a good one. Thank you.
Have a lovely evening.
All right. You too. Thank you. Bye.
Good night, everyone.
Good night.